Everyone, we're going to take a look at number 12 in section 3.6. In this problem, they want us to find the equation of the tangent line to the graph of this function, y equal 8e to the t times the quantity 1 minus cosine of t. And we're going to find that at t equal pi over 2. Okay, so we do need the slope of the tangent line, and that's going to be the derivative. So I need to find the derivative of this function. Notice I have a product of two different functions of t. Notice t is our independent variable here, not x. So I got 8e to the t times the quantity 1 minus cosine t. So I've got a product of two things. I'm going to use the product rule. Remember how that works? I take the derivative of the first function here times the second plus the first function times the derivative of the second. Now the derivative of the first function, since the derivative of e to the t is just e to the t, 8's a constant multiple, this just becomes 8e to the t, same thing. Right, derivative of 8e to the t is 8e to the t. Here, derivative of 1 is 0, minus the derivative of cosine of t is negative sine of t. So be careful, I've got 0 minus a negative, becomes positive sine of t. So I've got 8e to the t, 1 minus cosine t, 8e to the t times sine of t. Now I do have a common factor of 8e to the t, so I can yank that out, leaving a 1 minus cosine t plus the sine of t. Okay, so factor that out, and there's your derivative. I'm interested, though, of course, not in just the derivative, but what is its value when t is pi over 2, because that's where I'm finding the equation of the tangent line at t equal pi over 2. So plugging in pi over 2 into my derivative, I replace t with pi over 2, right? And then I can evaluate. Cosine of pi over 2 is 0. Sine of pi over 2 is 1. Make sure you know how to find those on the unit circle. So in parentheses here, I just have 1 plus 1 is 2. 2 times 8, 16 e to the pi over 2 power. So that's the slope. Again, you can, if you want to know what that is about, you can use your calculator to approximate it, but we have to give exact values, right, in Achieve with using symbolic notation. Okay, we do need the point. The point will be at t equal pi over 2, and then I need to know what the y coordinate of the point is. So I need to plug pi over 2 into the original function, right? Where on the graph of this function is the point? So I'm going to plug that in. 8e to the t is what? Pi over 2. 8e to the pi over 2. 1 minus cosine of pi over 2. Sorry, I made a little mistake over here. But cosine of pi over 2 again is 0. I just have 1 here, so 8e to the pi over 2 times 1 gives me that, 8e to the pi over 2. That's the y coordinate of my point. So I'm now ready to plug in. Notice my point slope form. Notice my independent variable is t, not x, because t is our independent variable in this problem. And so y minus y1, though the y coordinate of my point is 8e to the pi t. M we found is 16e to the pi t. T minus t1 is pi over 2. So it's kind of a nasty looking expression. If I solve for y, I can just add 8e to the pi over 2 to both sides. And this should be acceptable, I think. You can do a couple things. Obviously, we normally distribute the slope through here, which I've done here, 16 e to the pi over 2 times t right here. And then 16 e to the pi over t times a negative pi over 2. So 16 times pi over 2, 2 goes into 16, 8 times, I get 8 pi e to the pi over 2. Okay, kind of, sorry, I did that, just looks kind of weird, but I distributed 16 e to the pi over t times t is there, minus, remember the 16 and the 1/2 give me 8 pi times e to the pi over 2. And then this 8e to the pi over 2 I put there. Sorry, it was kind of confusing. All right, so I put that there. So there's the distributing this through these two terms gives me the first and last term, and then that one in the middle. Okay, and then and I do it this way because here's a t, right? This is the slope times t plus this is just a constant. Notice there's no value of t here. This is just a constant. So you can use your calculator to approximate what this is. We can also factor out a 8e to the pi t from both of these, leaving 1 minus pi, maybe make it a little more compact. So you could write it this way. There's lots of ways of writing. I think this is fine for Achieve. It's just a little messy, no matter how you try and deal with it in terms of writing it out, which is common again when we have finding tangent lines for functions involving the trig functions. Okay, I hope this is helpful. Again, as always, if you have questions, please let me know.